Evaluate each geometric series described. So again, you see this word series, and you should know that series means sum. But you also see this Greek letter sigma. And remember from a previous lesson, we talked about sigma. Sigma was the Greek letter S. S stood for series or sum. And so we're finding the sum of whatever this says. So remember, what we're talking about is finding the sum of, in this case, the first 9 terms from 1 to 9. So it's like we're adding up all of these apple baskets. So think about what we're going to do here. We're going to plug in 1. And so the first number we plug in is 1. So 3 to the first power minus 1. That's 3 to the 0, which is 1. And then we would plug in 3 to the 2. We plug in 2, and so that's going to be 3 to the first power, which is 3. And then if you wanted to keep going, plug in 3. That's 3 squared, which is 9. And we could keep going on and on and on and on and on. But I don't want to do that. That's more work than I need to do because we have a formula for this. All right, that's the same formula that you saw before. That's the formula for the sum of a geometric series. So we don't need all of that. We don't need all 9 of those terms. We just need a few. We need the first term, because that's what it says in the formula, right? A1. And so we just did that. That's if you plug in this first number right here, 3 to the first power minus 1. That's 3 to the 0, and 3 to the 0 is 1. So we know that first number right there is going to be 1. And then R is kind of tricky, I suppose. The R value right here. The R value is just going to be whatever this base is on the exponent. So in this problem, R is 3. And then in, it's not as simple as saying it's this number right here, but it has a very big part, okay? Basically, it's how many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. It won't always be this number at the top, but it will if this bottom number is 1. So you have to really think about how many terms there will be, how many terms there will be added together, and in this case, there are 9. And so anywhere you see an R, you're going to put a 3. Anywhere you see an N, you're going to put a 9. A1 was 1. So let's look at the formula here. A1 was 1 times 1 minus R was 3 to the 9th power, close parentheses, over 1 minus R was 3. Now, we're going to type that into a calculator, but be careful. When you type it in, you probably need parentheses there. Otherwise, you will not get the right answer. So let's look at our calculator. We have 1 times the quantity, 1 minus 3 to the 9th power, close them, divided by, I'm going to open up parentheses for the bottom and put 1 minus 3. Now, as an alternative to putting parentheses there, you could just say 1 minus 3 is negative 2 and just divide by negative 2 if you want, but I'm just going to do it like this and not have to do any kind of calculations at all. The number's kind of big, 9,841. Seems like it might be too big, but remember what you're doing. You're actually adding up all of these numbers. And so you're adding up a whole bunch of numbers. It's going to be big in this case, especially since this R value is 3. So evaluate the geometric series. That's what we did. Problem number 5, it's the same thing. Really just look at the formula and make sure you fill in the gaps. A1 is what you would get when you plug that in. So plug in 1. That's going to be 5 to the 0 power, which is 1. So A1 is 1. That won't always happen, but it does here. R is this number right here. And then N is how many terms there are going to be in between 1 and 8. So if you plug in 1, plug in 2, plug in 3, all the way up to 8, there are going to be 8 terms. So N equals 8. So let's plug into our formula. A1 is 1 times 1 minus R is 5 to the 8th power over 1 minus 5. Now again, I'm telling you, if you don't put parentheses there, you're going to get it wrong. So 1 times 1 minus 5 to the 8th power divided by parentheses 1 minus 5. 97,656. Let's do it again. Same things, we need the same pieces of information. So for A1, you plug in 1, plug in this number. So 2 times negative 3 to the 1 minus 1. This time it's 2 times negative 3 to the 0 power. Well, negative 3 to the 0 is 1, but you've got 1 times this 2, so you're going to end up getting 2 this time. A1 equals 2. Your R value is the base on the power. So the R value here is negative 3, and then N is going to be 9. So we have formula. A1 is 2 times 1 minus R is negative 3. I put that in parentheses. Be careful on that. If you don't put that in parentheses, you could make a mistake. To the 9th power over 1 minus negative 3. Put the bottom in parentheses or you're going to get it wrong. 2 parentheses 1 minus, put the negative 3 inside parentheses, and then raise it to the 9th power and close off the top. Divide by parentheses 1 minus parentheses negative 3, 9,842. Next says evaluate each infinite geometric series. And so your keyword here is infinite. It's kind of weird because it's like we have an infinite number of bushels of apples. We don't just stop at 6 or 8 or 9 or whatever. There's an infinite number of numbers being added together. And we've got a formula. And the ironic thing is the infinite series actually has a less complicated formula than the ones before. So it's very similar. You look at the formula and you see you need A1, and A1 is what you get when you plug in this first number. So we have negative 4 times 1/3 to the 1 minus 1. Or negative 4 times 1/3 to the 0 power. But anything to the 0 power is 1. Negative 4 times 1 is negative 4. We see that A1 equals negative 4. The only other thing we need in this formula is R, and that R number is just the base on the power. R equals 1/3. Forget about the 4 or whatever. R equals 1/3. So if we're going to find that sum, we just have to do A1 over 1 minus 1/3. If you want to use a calculator, that's fine. Just make sure you put parentheses around that expression. Negative 4 over parentheses 1 minus, I'd go ahead and put the fraction in parentheses as well. Negative 6. So it's kind of funny to think about, but what you're doing is adding up an infinite number of numbers, and if you add up an infinite number of numbers, you're going to get a sum of negative 6. We've got 2 more just like that. So find A1 by plugging in this number. 4 times 2/5 to the 1 minus 1. That's 4 times 2/5 to the 0. That's going to be 4. A1 equals 4. R equals 2/5. We should be able to plug in A1 over 1 minus 2/5. Use parentheses for the calculator. 4 over parentheses 1 minus 2/5. 6.6 repeating. or 6.67. If you did it as a fraction, that's 20 over 3. Okay, 20 over 3 is a good answer, but I would take 6.67. Next one, same thing. Find A1. That means you're going to plug in 1. That's 3.3 times 0.8 to the 1 minus 1. You've seen this enough times that that's going to cancel out, and you're just going to end up getting 3.3. Your R number is the base on that power. So you've got A1 is 3.3, and R is 0.8. You do the exact same thing. A1 over 1 minus R, parentheses, 3.3 over parentheses 1 minus 0.8, 16.5.